It can also denote an event. For example, some terrorist attack has happened. And then we want to know that, okay, where the attack has happened, how many casualties have been there, who are the affected people. Okay, and so these are all the these are the critical information that we may like to know for information extractions. So typically, named entity was emerged as a part of that. So to give an example, let's say if this is a document, and in this document you see there is a date mentioned, there is a time, there is a location, there is a speaker name, then there is a title of the talk, the abstract of that particular presentation, and the biography. Now, what actually we do, if I ask you that who is the speaker, you can easily get this information from this. If you write a regular expression and do the pattern matching, from that you can easily identify that here the followed by the speaker, whatever appears, that actually is a part of the person name. If I ask you that when the talk is scheduled, you can get this information easily because date information is mentioned here, the Friday, March 24. When the talk is scheduled, the time you can mention, the location where the talk is scheduled, the particular venue, that also is mentioned. Then an abstract, then the biography. So you see that extracting these information, the date, time, when the talk is scheduled, where the talk is scheduled, who is the speaker, what is the title of the talk. These information are not difficult to extract. They are easier. You can do it easily using regular expression. But if I ask you that what are the names mentioned inside the abstract, then you cannot really do it by writing a regular expressions. So for example, if you have this date, time, location, speaker, easier, but this person name identification, let's say this is a person name, this is another person, this is the person name, this is person name. These are all the person names, okay? And this person name identification is a critical task, okay, which you cannot achieve by writing a regular expression like you are identifying these slots. You need some kind of specialized treatment. Now, this is what the named entity recognition is a part of. So typically what we do is that in information extraction, if you have any document, if you have a predefined slot like this, name you want to extract, title you want to extract from this document, organization name you want to extract from this document, then come up with the mechanisms, come up with the process, and using that process, you identify what are the names here, what are the titles of those names, their positions, and which organization they are employed. Like for example, then at the end, you will know that these are all the names. These are the title of these. Bill Gates was the CEO, the VP, founder, and these are the organization names. Now, as a total information extraction, we mean this. You will have a template, you will have a document. You have to extract the relevant information from the document, and you have to fill those information in the specified slots. Now, the very first thing that you have to do in information extraction is the segmentation of this text. That means document is given, you identify the sentences. From the sentences, you identify the words, etc. Those are all part of the segmentation. We can also call them as the named entity extractions. So you are identifying the potential names, like Microsoft Corporation is a name, CEO is a name, entity, Bill Gates is a name. So these are all the names, named entities. Then once you identify that, the second step is that you have to categorize these names into one of the predefined set of groups, which is a part of the classifications. Like here, Microsoft Corporation, this Free Software Foundations, all are belonging to the named entities of type person. Then, for example, CEO, Vice President, Founder, these are all the titles. Then Microsoft Corporation, here the Microsoft Free Software Foundation. These are all the organizations. So you see that we are extracting the name first. We are classifying the names into predefined set of categories. So you have segmentation plus classification. And these two things together is basically the named entity recognition and classifications. We can do then association and then clustering. So what is the association means? Once you have done the classification, you actually have to find out some kind of relationship between the different entities. For example, this Microsoft Corporation, Bill Gates, is connected by this CEO. The CEO is the relationship. We call them as a relationship extraction, which itself is a research problem in natural language processing. So we extract the names, classify the names, and then you also, in the third case, what you have to do is that you actually have to do a kind of the relation extraction. Okay, and that is done by association rules. Association rule binding is an important concept in data mining. So I'm not going into details of that, but you have to know that it finds the relation between the different records, that how two records, two entities are appearing frequently in the data. That basically is the association between them. So once you do the association, then you get this different chunks. And finally, the cluster. And if you do the clustering, then you have these, that names, titles, organizations. So these are all the different groupings that you are doing. So now totally, when you think about information extraction, it is actually a multi-step process. The identification of the segmentation is the first, then the classification, then association between the named entities, and finally the grouping of the named entities. And when you talk about named entity recognition, the named entity recognition is the first two part, the segmentation as well as the classifications. Now, this is what the named entity recognition. In the literature, the named entity recognition and named entity recognition classification term, they are interchangeably used. Okay? So typically, the idea is that you have the set of named entities, you document is given to you, identify the potential named entities, classify them into one of the categories, and the categories may vary. For example, typically the categories can be the name of the person, the name of the organizations, the location name, the miscellaneous name like date, time, number, percentages, monetary expression, measurement expression, etc. And depending upon the type, if you want to do, let's say, website name recognition, then email address can be a potential named entity. If you are doing the processing of a biomedical text, a chemistry text, then the chemistry names will be a possible named entity. Biomedical names will be the possible named entities. So depending upon the genres, depending upon the application, depending upon the domain, the names could vary. Now, let us see that this particular problem of named entity recognition actually began in 1995, 1996. And how they did that? So it was a part of DARPA. So DARPA sponsored research program. The DARPA is the defense organization of US. So they conceived that since the internet was getting very popular, web documents were getting populated in the internet, plenty of documents were being generated. So keeping track of those documents, what the people are talking about, who is talking about, are they talking about a specific organization from where the document is generated? So these are the all critical information from the security point of view, law and order point of view. So the US organization, Defense Research Organization, for the security purposes, want to extract the relevant information from the internet document. And they actually started this, you can say it's a kind of hackathon, an open challenge, and define the problem of information extraction, release the data. Different teams participated in identifying the named entities, and it was all in English language. And they actually identified 7 different named entities. The person, the location, organization name, date, time expression, is there any monetary expressions are mentioned, the percentage also they thought to be important. And this task was not very simple because from this particular text, you can identify that this Washington is actually the name of a person. This S is not a part of the named entity. This MS is actually helping you or giving you a clue to recognize that the entity that is appearing after this will be the potential person name. Then here now you see that capitalized letters. If you see that English names, English proper names are always capitalized. Okay. And this capitalization happens because of the beginning of any word, if it is capitalized, so it can be a potential candidate for the named entities. Okay. Like MS Washington's candidacy. So here, Washington, you see, starts with a capital letter. So it can be a potential named entity. MS is also capitalized. It is not a named entity because it is a giving you a hint that the next can be a kind of entity. Okay. Then another interesting thing here, you see the chairman is capitalized, John is capitalized, Dingle is also capitalized. But this chairman, John Dingle, is not a named entity. Altogether is not a named entity. It may be capitalized. John Dingle is a part of that, but it starts with J and then it starts with D. Okay, right? Both are capitalized. But this chairman is not a part because chairman is helping you, although it is capitalized, but it is not a part of the named entity. Here this is capitalized because it is the beginning of the sentence. Then here this one is a named entity, the Michigan. You see it has been abbreviated. In short form you have written. Now you have to identify that even if it is written in the short form, it is a named entity. Washington is ambiguous. Typically it is a location name, but in this case it is a part of the person. How do you do the disambiguations? Then you see the last one is more complex. Here it is House, Energy and Commerce Committee. And is a connector between them. And is not capitalized. House is capitalized, Energy is capitalized, and is not capitalized, Commerce C is capitalized, Committee C is capitalized. So if you define a rule, the set of words that starts with the capital letter is a part of the entity then House Energy become a part of the entity. Commerce Committee also become a part of the entity, but and is not a part of the entity. That should be because it's not capitalized. But in this case, and is also a part of the entity. And this entire thing, that House Energy and Commerce Committee, is an organization. Now, sometimes, now if you say it is Dell and Microsoft, Dell and Microsoft structurally very similar, but Dell and Microsoft cannot be a single named entity. They are two different entities. And in this case, is a connector between them. It is not a kind of part of the named entity. So you see that these kind of ambiguities will happen, and depending upon the types of the domains, uh, the, the kind of named entities can vary. For example, it can be email address, web address, street address. If you are dealing with the biomedical text, health related text, then it can be the name of the drug, medical conditions, ship name, bibliographic references, etc. So detailed guidelines you can see as part of MUC 7, the Message Understanding Conferences 7 guidelines. Okay. Now, there are plenty of different problems, okay, that named entities are generative in nature, because if you think that it is not a difficult problem at all, I will list all the named entities, okay. I will list the person name, I will list the organization name, I will list the location name. So all the databases you will maintain, and then you will simply do a search, and then you will do the labeling of named entities. But this is not such a easy task, because listing all the person names is not a feasible task. New names can be invented. It can be added to the dictionary, to the database. It will make the database very huge, very complex. The named entity can appear in many different forms, like Professor Manning, Chris Manning, Dr. Chris Manning. So all these variations can happen. So how to capture those variations? It can be ambiguities also, like Washington, location versus person, May, person versus month, Ford, person versus organizations, 1945, date versus time. So all these things are actually very ambiguous. So how to do this ambiguity handling? How can you do this? Even for Indian names, the challenges will be even more. For example, many common words that may appear in the dictionary with a different meaning, like Kobita. So Kavita can be the name of a person as well as Kavita has a poem, the meaning. Now, when it is a person name, when it denotes a poem, that disambiguation you have to do. Then there can be some cases where every line is a named entity. Like, for example, here you see this is the named entity, first one, organization, second one, organization, third one, location, fourth one, location. So all these are different lines are basically different named entities. Now it has plenty of application for information retrieval. If you know the names, that actually can help to retrieve the document. If you know the names, that actually help you to extract the relevant information from the document. So in that process, for document accessing as an index, for information retrieval, for retrieving the relevant documents for a name, or the extracting the relevant information within the document. So these kind of tasks will be very easier if you know the name entities. Higher level tasks also, like translation. You are translating from one language to the other language. So if you know the name entity always has been a problem for missing translations. Okay. So it is crucial to decide what should be translated and what should not be translated. So there are two terminologies, translation and transliteration. Transliteration, you are just writing the words in the Roman font in the target language. And translation is the complete translation. So here is an example, Jadavpur Vishwavidyalaya. will be Jadavpur University. Now, Jadavpur, the first, this one is the transliteration, but the Vishwavidyalaya is basically an university, which is translation. Now, it is important to know what to be translated and what to be transliterated. Typically, since named entity handling is a problem in basic translation, so if you know that there is a named entity in the input sentence, input document, then it is always a wise decision to transliterate it rather than translation. Automatic summarization, that summarizing the document into a smaller set is a summarization problem. It is very important if you know there are names in the sentences, those sentences should be given more importance than the other sentences. If I give you a 100-line sentence and ask you to summarize in 10 lines, if there are a lot of names appear in a sentence, you cannot ignore those. So those will be very meaningful because named entity convey the meaning, the content. Okay? So ultimately, something that has more entities, more names will appear as a part of the summary. Now, the question answering systems is also can be assisted with the named entity recognition. Many cases, the factoid question answering, let's say who, when, what, answer to these questions that who did, when it was done, these kind of questions will be assisted by an entity recognition. Okay. Now there are also, that means if you know the named entities, then answer to these questions can easily be retrieved. In speech also it helps. For example, if you are pronouncing a telephone number, date, then actually it is very helpful. Okay, out of what vocabulary problem, solving that is also a can be assisted with the named entity recognition. So it shows that named entity recognition, although is a lower level task in natural language processing, but it actually has it is a kind of shallow parsing. So you have the lexical analysis, you have the syntax analysis. You can consider them as a kind of, you don't need to do the full parsing, but it is a kind of shallow parsing, and that is what the named entity is. And it actually helps in doing various higher level tasks. Okay. Now, what are the data set available? Very well-known data. For example, as I mentioned that 1995-96, the hackathon that DARPA conducted is the Message Understanding Conferences. As part of that, this data was made available. Then Cornell, the computational natural language learning, named entities in English, German were made available. Named entities in Spanish, Dutch were made available. Automatic content extraction like English, then Tide surprise language, introduced the Hindi first time in 2004, 2007-8. There has been a competition, shared tasks for named entity recognition in South and Southeast Asian languages, particularly covering Bengali, Hindi, Telugu, Oriya, Urdu, this kind of languages. Now, all these are the generic domain. Then very specific to the biomedical domain, chemical domain, health. Also, there has been a lot of, let's say, open problems. And there has been a need that how NLP can be combined together with the, can help in the biomedical task. So it is known as the bio-NLT, that biomedical natural language processing. Or biocreative, for example, is another area where people also focused on solving various tasks providing a lot of data. AI made I2B2. Then the social media was gaining popularity. So 2014, there has been a competition against shared tasks for extracting the named entities from the tweets as part of this particular conference, this workshop. So what typically it is done, if you see that message understanding conference data, the corpus, the uh, uh, the corpus looks like this. This is the XML tagging, right? So for example, Inamex type is the location. So this part, this is a location name, end of the location Inamex, then date, so beginning of the date, end of the date, time expressions. So we are presenting a text and their annotation was done like this. And then different organization has different kind of way of representing the text, representing the sentences. Now also there are various efforts, for example, starting from rule-based methods by writing the rules for named entity recognitions based on the databases, based on the patterns. Then automated system was there that focused on statistical natural language statistical methods, the machine learning based methods, for example, supervised, semi-supervised, unsupervised way of doing identity recognitions. Then there are hybrid system, which is a combination of handcrafted plus automated systems. So there are various literatures, plenty of talks people have done already. But typically, the learning system in most of the NLP, like most of the NLP tasks, is more adaptable because you really cannot, do the the kind of, let's say, adaptability to a new domain that may not be very easier for a rule-based systems. You can write the rules for doing an identity for the domain of, let's say, the literature, domain of news. And then if I ask you to do the name recognition from the medical text, now maybe as a person, you don't have any expertise in the medicine. So you cannot handle it now. So what we need another group of people who are expert in medicine. Then I want to do it for the science and technology. Then you need another person. So you see that knowledge engineering based system, rule based system always has been a issue for the domain adaptations. Then we have the learning systems like easy adaptability. Uh, if you have the good amount of training data, you can build the models. It actually requires the large amount of annotated data, okay, to get the reasonable accuracy. Then we have the annotators also, if they're okay, that they're cheap to get, then fine. But if they're not, then how to pay them? So it can be easily trainable, adaptable to the new domains, new languages, right? That is how the learning system is different, and in also for named entities, this is important. So I'll directly go to the learning system. So there are various works. For example, you see that for rule-based system like LTG is a very well-known rule-based system. Then IBM's Nominator was a rule-based system. Then another one from University of Sheffield's, this gate architecture is a very popular, you can say that, okay, is a kind of NLP toolkit. Like for example, Stanford NLP toolkit, you have that NLTK. Gate is also such kind of toolkit that does multiple tasks starting from tokenizations, named entity extraction, co-reference resolutions, etc. So then like this one is the gate. For example, you present it a document, it can do the annotations. All the named entities will be highlighted depending upon their types, kind of the types, and they will be marked, highlighted in the text. Okay. So then you had in case of learning system, what we need is that manually label data. Okay. But one important point in named entity recognition, if you are doing using machine learning, you have to actually detect the boundary, that where a name begins and where it ends. That is a very important step because name is not always a single word entity. So you have to assign a label for a group of tokens, sequence of tokens. So how can you do this? Let's say India played with Vivian Richards. In this case, there are quite a few technique exist in the literatures. So typically, this is one of the way how the boundaries are marked. Like if this is the text India played with Vivian Richards, now India is the location and it is the beginning of the location that you mark. Played is zero, with is O, not zero, this is others basically, the outside of the named entities. And BXS is the first word of the name. IXS, all the other words in the name. So for example, Vivian Richards, there are two words. The starting word is Vivian, that is annotated or labeled as beginning of a person. This is the continuation, so it becomes the intermediate of the person. Played and with are not a part of the names, so they are annotated as O, the others outside. India is a single name, location, so it is annotated with block. Okay. Now, how to do these computations? How can you do? So typically, what we are actually doing, given a particular token, we actually want to find out what will be the tag. Tag here is the named entity tag. That means if you are given Richards, you have to see what is the probability of I per given Richards, what is the probability of B per given Richard, what is the probability of O given Richard, what is the probability of B log given Richard. That means what given a particular token, you actually have to compute the probability of each and every possible named entity tags. And whichever is maximum, that will have to be allocated. So for example, in this case, if for Richards, I per has the maximum probability from this computation, then I per will be the possible tags for Richards. For named entity, the contextual information is important, local contextual information. So let's say when you are computing the probability of the current tag, then not only the current token, like token I, but also the preceding token, following tokens may also play an important role. So you see that probability of any tag may depend on what has been the previous token and what is the following token. Okay. These two may be also important so that local context may help in predicting the current tag. Then we have the decision trees, like for example, people have used as part of machine learning for doing named entities. A hidden Markov model was extensively used. Maximum entropy-based Markov model was used for doing named entity recognitions. But all these are the classical machine learning algorithm. It requires the handcrafted features. It is not deep learning. In deep learning, you don't have to be worried about the features. But here now you have to worry about the features. Now the question is, what will be those features? The features can be the words itself, the lexical features. It can be the part of speech informations. It can be the orthographic information, the how a word is constructed. It can be the different affixes like prefix, suffix, etc., the gadgetiers, etc. And you do the extraction of the features from this. Okay. So this is one of the very pioneering work based on hidden Markov model. And the kind of features that they had used, are these, and this was for English. Whether the word is capitalized or not, these features check that. Numeric symbols, whether the word contains the numeric symbols or not, that is a feature. Whether the word contains the punctuation marks is a feature. The position of the word in the sentence is a feature. And also different orthographic constructions. Like, for example, if the word contains a digit and dash is a kind of features. Okay, contains digit and comma is a kind of potential. It can denote the amount, right? So a kind of like you can see here 23,000. So these kind of features were used, and they did a lot of experiments. The another very pioneering work in identity, if you are interested, you will see in 1998 that was from the New York University. And this was actually based on maximum entropy based named entity recognition. It was a hybrid model where a rule-based named entity was combined with a machine learning based named entity. And what kind of annotation schema they had used to detect the boundaries, they actually made a difference. So for example, if there are more than two words, then the starting word will be annotated with start, then all the intermediate token will be the continuations, end of the token will be the end. Unique will be the unique one, then it will be a kind of a named entity category. Okay. Now you see that here that the maximum entropy based model, okay, so that actually has done the name was labeled with a different encoding schema. Okay. Now they also use a lot of features, that local features, whether the token begins with capitalized letter, token is a 4-digit number, lexical features like the context window, dictionary they maintained, the gazetteers, the first name, the company name, date, abbreviations. Then the external systems like whether the current model, current sys token is recognized as an entity or not. So these were all the features. So now the local contextual information is okay. Another very interesting work that was done in 23 is that how to actually incorporate the global information and why global information is useful. Let's see this example. That Mary Kay names vice chairman. Okay. Now, if I ask you that whether Mary Kay is a person name or not, now local contextual information means what? Surrounding 2-3 words. Let's say you are using names as a word, vice as a word, or even chairman. So this is a local context, names, vice, chairman. Use that as a feature. Now, based on that, are you able to decide whether Mary Kay is the person name or is an organization name? It may be an organization name, it may be a person. And based on this local context, you are not able to decide about this. Now, what is the way out? How can you actually do this? Okay. So that can be an interesting idea, right? So now, in the same sentence, if you see that there is another sentence like this, that Richard C. Bartlett was named to the newly created position of Vice Chairman of Mary Kay Corporations. Now here you see that Mary Kay Corporation, this particular designator is a strong designator for an organization name. Okay. And that actually helps you to decide that Mary Kay was not a person here, that Mary Kay should probably be an organization. But this local context is not helping you. If in the same document you have another sentence, and in another sentence you have already very much sure that this is an organization, then you are actually using this information to decide that this also be an organization, not a person. So that means what? You need the help of the entire document. Okay, that actually helps you to decide that this is a kind of organization name. So this is how the global contextual information helps. And they actually used an interesting, uh, interesting uh, annotation schema, right? So they actually use like this, that uh, beginning of an identity was the, here the person, let's say the person begin, end of the person name, person end. The rest are not named entity, not named entity, not named entity. Then house is an organization unique. Stuffer is not a named entity. The is not a named entity. Securities is the beginning of an organization. And is a continuation of the organization. Exchange is the continuation of the organizations. Commission is the end of an organization. So they are doing like this: the beginning, continuation, all the intermediate one, and the end is denoted by end. If there is a single word, then you are using this unique. Person unique means there is a single word named entity of type person. That is what they had used. And then their model was based on maximum entropy, which is unlike the hidden Markov model. It is a kind of discriminative model. And what it does, that it computes, let's say FA is a feature, indicator feature, SI is a state, O is an observation. So what it does is that given the observation at this particular state, it checks whether that particular feature is true or false. If this is true, then the value will be 1. If this is false, the value will be 0. And each of these features is actually weighted by this particular factor alpha of A, which is the weighted factors, the parameters basically. Okay. So that was one thing. And then they used a lot of features, like what were the first word was a feature, the actual word string is a feature, out of word vocabulary, a lot of local features like this, whether the word is a capitalized followed by a dot, there is only one single capitalized letter. So there are various other features they did. Okay. There are plenty of works in different languages like Arabic, Bulgarian, Catalan, Chinese, Japanese, Dutch, and depending upon the language, their characteristics are different. So the challenges will also be different. Then multilingual is another one, mixing of the languages. How can you deal with this translation? Indian languages are more challenges because languages are morphologically more richer. Data is not available. So how to handle such kind of situations, right? So we did a lot of works. I have also listed here that particularly for machine learning based system in different languages, like for example, that is carried out by the different institutions, including there are some works that we have done. For the Indian languages, there is two data sets. One released in 2007, the other one is 2008. Okay. The another deeper problem of named entity is that how can you do the fine-grained analysis that not only organization, but if you now want to know that whether what type of organization it is, whether it is a commercial organization, whether it is a division, whether it is a government organization, whether it is charity donation, whether it is international organization, whether it is a political entity, what kind of organization it is. So you are going into differs, more fine-grained analysis of the named entities. Okay. Also, there are various other things for, let's say, what could be the good features. There can be language-specific features. Then there are interesting problem. I can tell you that like how can you actually develop an identity that can work for more than one languages, that can work across the domains. Across the domains means, let's say that newspaper domain you have developed, can you adapt it for technology domain? Can you adapt it for the historical domain? Can you adapt it easily for the literature domain? Then the fine-grained identity, like not only person, what kind of person, sports person, scientist, what kind of scientist, physicist, chemist, biologist, computer scientist. So this kind of fine-grainedness in terms of ontology can be good research problem. Also, the identity, if you see that in history, archaeology, literatures vary. Okay. In chemical, biochemical names also it varies. So there have been a lot of works that is happening, okay, in this front, and there are a lot of resources that are popular resources. If you see the Stanford in here is based on conditional random field. It focuses mainly on English types. The cover is person, location, organizations. Link pipe is another one, which is hybrid machine learning plus rules. And they only focus on person, location, organization. They also can do the biomedical text like chemical names, organisms, gene names, etc. TextPro is a very popular tool based on support vector machines for European and English languages. Gate is, as I showed you, it is also interesting. Banner is mainly for the biomedical entities and based on conditional random. Genia Tiger is also based on the biomedical entities. And there are important data set like mark data set, funnel, this JNLP BA24, BioCreative, IJNLP, shared tags data sets, Twitter, NER data sets. So these are all interesting data sets that are available. Still, people are doing a lot of research in identity recognition, but mostly now based on the neural network based, deep learning based. And the challenges will be different. Let's say code mixing, Indian languages, mixing of languages, how to do the name identity recognitions. Biomedical names, healthcare text will have a different challenge. The names will be very long. Chemical compound identifications. Okay. These are all the very, different nature, very specific nature of the problem, depending upon the domain, depending upon the genres, the, the structure of the named entities will be different. So capturing them, identifying the relevant features will be an interesting idea. Okay. So if you have any question, you can ask me now. So it is better that I hope you got some ideas about named entities. Uh, if you want to know anything about this, please feel free to ask me questions. Anything that you want to know. Any questions about named entities? I think last time uh, I got a question that named entity probably somebody wanted to know, right? So is it okay to get an idea about what is named entity, some of the challenges, uh, and what should be the possible ways of doing?